Hi friends. So today in module 3 we will be studying about the features of cloud. And what should be the features of cloud, right? For a cloud native, what should be the cloud native features? So the first feature should be that the software should be running on the generic hardware. The hardware and software should not be dependent upon each other. Any vendor software can run on any generic hardware as well. So that should be a very important feature of cloud native. Avoid vendor lock-in. That is the same thing, that there should not be vendor locking, like vendor A, vendor B and C cannot work each other. They all should be interoperable. Third feature must be that the capacity of a cloud can be grown as per the need. So there is a feature that you can pay as you grow. So if you are working on cloud and you need to increase your services, you need to scale the limit, then as per the scalability you can pay for those cloud services. That should be a feature. And it's very important feature that it should be automatic software upgrade. Automation, in short, automation should be there. Any software upgrade is needed or any kind of changes is needed, so that should be automated on the cloud. So few things are important part of cloud, that is microservices, open and declarative APIs, immutable infrastructure, and DevSecOps. These are few important you can say building blocks of a cloud. So let's understand one by one what are they. Microservices. So microservices are you can say that suppose these are 4 microservices. These are separate microservices. So every microservices, right, every microservices should be separate from each other. They should be loosely coupled. They should not dependent upon each other. So if we have to deploy this microservices, so we can deploy this microservices only. If we have to upgrade, then we can upgrade this microservices only. If there is a problem and we have to heal this microservices, so these microservices should not get affected. So like this. So these microservices should be loosely coupled with each other, right? And if we have to scale this microservices, then it should not be depending upon these. So that's why these microservices, and these are in containerization. I mean, these comes in the form of containerization. So what is container, we will see in next topic. So these are microservices in a cloud. So they should be loosely coupled and independent upon each other in terms of flexibility, scalability, and programmability. Now, what are virtual machines versus container? So let's see that what are virtual machines and what is the container. So if you see the cloud infrastructure, the cloud structure, you will see the hardware is in the base. Then there is a host operating system in the second part. Then there is a hypervisor. Then there is a guest OS. This is guest operating system. There are 3 guest operating systems here. If you see 3 guest operating system, above that there are libraries, and above that there are apps. And these apps are virtual machines, virtual machine 1, virtual machine 2, virtual machine 3. So in the generic thing, if there is no containerization, then you can see each VM has its own operating system. There are 3 operating systems, 1, 2, 3. Like on these operating system, the apps are configured. So each app has its own operating system. But in containerization, in container, what happens that this is hardware. After that, this is host operating system. Then this is container engine, that is one OS for all. Here it is one OS. So like this, here was different, you see, different guest operating system for every application, but here is this container engine. Above that libraries are there, and above that application is there. So then this is called container 1, container 2, container 3. So all these containers are on the same operating system. So that is the difference between these virtual machines and in the form of containerization. So you can say that the container is the basis of microservices. So you can say these apps are the microservices, you can say in this, and containers are a bit more evolved form of virtual machines. So containerization are better nowadays. Containerization is better than virtual machines. Now, next thing that is important for our cloud native, that is open API. Now, what is the API? API is application programmable interface. So you can say that API, application programming interface. Interface means the interface which helps applications to communicate with each other. That is API. Suppose there are two applications are there, app1 and this is application 2. Then there must be an API in between them to communicate with each other, right? So APIs allow different applications to talk to each other. API enables communication among microservices also. Why Open API? What is Open API? Open API means that the API must be programming language agnostic. I mean, the Open API should be able to communicate between two applications of any programming language, can communicate between any programming language. That should be open. That is called Open API. It should not be dependent upon the particular kind of programming the application has been designed, kind of that. Now, what is next thing comes? What is declarative API? So declarative API, the name is suggesting that declarative means that has been declared earlier. Declarative API. So like that, this is the current API. Sorry, yeah, current. That is not API. Hold on. This is current state, and this is desired state. So if you will see that from current state, we just have to give the desired state, and then we need not to worry about how this desired state will be achieved. The declarative API will do it on its own. So if we need to configure few resources with a particular, if we want a particular configuration in the system, then declarative API is needed. So what we can do, we can put that thing in declarative API that we want this desired state. Then we need not to configure this desired state. The declarative API will configure this desired state. That is declarative API. So the onus of doing configuration is shifted from system to, is shifted to system from consumer. So consumer doesn't need to worry about how the desired state would be achieved. Through declarative API, that state can be achieved. The next is infrastructure agnostic. So as I already said, that any vendor software can work on any vendor hardware. That is infrastructure agnostic. So the cloud should be infrastructure agnostic for flexibility. Another important aspect is DevSecOps. So DevSecOps means nowadays you see the consumer may require different kind of software changes on the go, that they want this feature, they want this feature. So to cater that demand as soon as possible, this thing comes into picture, that is continuous integration, continuous delivery and continuous testing. So this is a cycle that goes on continuously. So whenever, to cater the dynamic demands of the consumer, so whenever there is a demand, so the software changes of the software can be delivered fast. So for that, this is DevSecOps. Sec means security, development and operation. Sec stands for security. So that system must be secured as well. Security is an important aspect. Now these are few important features for cloud, and then there are two organizations which are helping to develop these cloud functions and all. So one is CNCF, that is Cloud Native Computing Foundation. So this Cloud Native Computing Foundation, it's a division of Linux Foundation for open source software. The CNCF is an organization of division of Linux Foundation for open source software. So there are approximately 150k contributors in this. It's an open source software, 150k contributors, and 796 members are there. So the members list includes AWS, AT&T, Cisco, Huawei, etc. Like this, Intel is also there. So these kind of companies are the members. So it has 796 members. So they are now responsible for developing this cloud system. Different kind of applications, protocols and all, they are developing this. Then this is Nefio. So Nefio was a project launched by Linux and Google Cloud to enable and simplified cloud native automation. So this Nefio deals mostly with automation. So the automation part of cloud is seen by this organization Nefio. Again, it has many members. It's again a part of Linux and Google Cloud to enable and simplify cloud native automation of telecom network functions. It's a new open source technical project. Enables fast provisioning of network functions. So through it mainly deals in automation, helps in automation, the development of automation, and through automation, network functions can be provisioned, can be produced faster in the system, in the cloud system. So these are two organizations mainly working for cloud evolutions. So that's it. These were few features and a brief about the organizations which are working for this cloud evolution. So in next session we will know further about this cloud native thing of this telecom. Till then, take care. Thanks a lot.